So this is going to be a relatively concise final exam review. I'm not going to be going over any problems, but I will be talking about what topics to focus on, logistics, format of the exam, and so on. So when is the exam? Well, it is on Tuesday, May 11th. It is going to, logistics wise, it is going to be consistent with exam 1 and exam 2, meaning it is going to open or be available on Gradescope at 12 noon Eastern, and it is going to run all the way to 11:59 p.m. Eastern. So a full 12-hour window is going to be, you can take that exam during that 12-hour window. How long is the exam? Well, you will have 3 hours to finish it. You will not be able to take breaks. Why you should make the exam 4 hours? No, in my opinion, the ideal time for an exam is about 2.5 hours. After about 2.5 hours, I would not expect students to be at their best in terms of answering questions. So 3 hours, I think, given that you have scanning and uploading time as well, I think 3 hours is sufficient for that. I mean, make the exam time 4 hours, but 2.5 hour exam. Well, the exam itself should not take you full 3 hours. I'm going to give you some, room to work with over there, um, but you will have a 3 hour time to finish it. So once you start, the countdown will start for your 3 hours. So unfortunately, you cannot take breaks. You will have to do it at a stretch. Now, in order to get the full 3 hours, make sure that you start the exam on or before 9 p.m. Eastern time. Uh, let's see, there are a few questions coming in. 3 hour exams are marathons as it is. I know it's already too much. Is that A really don't want to do that? Yeah, don't do that at 8. You do that early. Will there be more questions than the previous exam? Yes, there will be more questions than the previous exams. But your answers will also be quicker to obtain. Um, so there's a balance there. I'll talk more about that. Let's see. In order to get the full 3 hours, make sure that you start the exam before 9 p.m. Eastern. Do we have an approximate question count? Yes, we do. When we talk about the format of the exam, I will talk about that. Um, After the submission, please go back and check if the submission went through okay or not. Now, this responsibility falls on every student. Um, Many of you know that I'm not going to be at my 100% on the final exam day just because of my knee surgery the day before. So, you know, I want you guys to take care of that submission, making sure it went okay. Uh, for each student, you take up that responsibility. What is allowed during the exam? Exactly the same things that were allowed in the previous two exams. Open book, open notes. You can access any resource that is available on Piazza. You can use a non-communicating calculator. And of course, you can use writing supplies. So that's allowed during the exam. Now, what is not allowed during the exam? Make sure that you do not interact with anyone during the final exam. And depending on how my condition is going to be on May 11th, I'm going to try my best to be available on WebEx Teams for a quick response between 3 to 6 p.m. Eastern time. Will there be office hours during reading days? Unfortunately not, but I can schedule some one-on-one time with you. You can schedule something with me through WebEx Teams. So text me and then we can set up a time. All right, so during the exam, and this is important, you guys, during the exam, if you have any question, I'm going to try my level best to make sure that each and every question is sort of crystal clear and something that you should not be really needing a clarification on, I'm going to try my best. But just of the off chance that you do need to uh, ask me a question, you send me a private chat on WebEx Teams, and I'll try to respond as quick as I can between 3 to 6 p.m. Eastern. Why is that the time that I've chosen? It is because that is the official time that has been assigned to CoCO final exam by the registrar. Let's see, few questions that are coming in. Should we email you if you have questions, or just post it in the general CoCO WebEx Teams chat before or after the exam? Before the exam, you can post it in the general CoCO WebEx Teams chat, and whoever is able to help you with that works for me. The TAs might be able to help, I might be able to help, or your peers might be able to help. But nothing during the exam. So on the exam day, please don't post anything. But before that, you're obviously welcome to use that to as a means to communicate with your peers. Please don't do the number system stuff. Oh, we got to do that stuff. We got to do well. It's not going to be the same kind of way we did it for the first exam, but we got to do some number system stuff. It's sort of fundamental for the class. Let's see. Are you going to be posting practice exams to Piazza like you did for the previous exams? Um, I will post some exams. uh, I'm not sure if they would be final exams or not, but I'll try to do my best in terms of back exams for the final. Let's see. So like on Tuesday 5/4, starting of reading day, the TAs won't have office hours either. Yeah, the TAs are not going to have office hours either after this week. Um, but if you guys need my help, like I said, I you know you no, I am recording this. I am recording this on a different platform. I'm recording this using OBS, just the way I have been recording for the last year or so. I can't rely on WebEx Teams or WebEx Meeting to do that recording really well. Don't worry, I have you covered. All right, so let's see. What were we talking about here? Right. So even though the office hours are not going to be there, TAs have exams too, and undergraduate student assistants have exams too. That's absolutely right. So that's the reason why I'm saying if you post it on the class WebEx Teams page, then whoever is available might help you out, right? So, and the way I see it is that this semester the help has been pretty quick. That's my assessment. I don't know if you guys agree or not, but I don't see that a question has gone unanswered for even a day or so. The support is already there. Um, the TAs or undergraduate student assistants are answering, or I'm answering, or you are answering your own questions. So you know, uh, you guys should feel free to post over there. Would you guys agree that the help has been pretty quick to get in this course, or am I seeing it incorrectly? All right. Okay. So hopefully we can continue that same thing for the next 1 week. Let's see. What was I saying? Yes. So if you guys plan to take the final exam between 3 to 6 p.m. Eastern, that is going to be really good. That way, uh, I can make sure that I'm available and be able to respond quickly. But like I said, when I write the final exam, I'm going to be spending a lot of time making sure that there are no typos or there are no potential clarifications that we might need to go through during the exam. Uh, but even if there is a typo and there is a mistake on my end, then you will not be penalized for that, right? So you guys can still go ahead and answer all the things just as they appear, because it's not going to be your fault if there is a typo. All right, so I want to emphasize a little bit more about discussing the final exam with anyone in this class or with anyone. Um, I'm sure you guys don't know this, but many students in CoCo have paid a pretty big price when they have not been very honest in terms of following the rules for the CoCo exams. And I would hate to see any student uh, that would have to deal with it for an important exam just like the final exam. So you know, I've not mentioned this to you guys until now, but there have been instances this semester where things have gotten ugly, and there have been students that have paid a big price. Uh, so I don't want anyone to kind of have to deal with that, especially for a final exam. Let's see, we won't be able to. Who actually? Uh, oh my gosh. All right, so here we won't be able to do regrades for the final exam. You will be able to do regrades for the final exam, but you will have a very short window. You will have a very short window. So in the past, I have released the final exam grades, and maybe I've given like a day for regrades. You will have to be on top of it. So as soon as it gets graded, I will give you guys the solution. You'll have to go through it, check it, and let me know about any regrets within a very, very short duration, maybe like a day or so, uh, because after that I'll have to wrap things up with submitting your grades. But to answer your question, yes, there will be regrades for final. Let's see. Let it be documented that. Oh yeah, yeah, yeah. Okay, I'm going to. So there are many things I could say right now. All right, I'm gonna. It's sort of giving me a headache because the options of a comeback here are so many. Let me just, move past all of that. No, I'm just going to move past all of that and talk about what is not allowed during the exam. Please do not consult or talk about this with anyone except for me. All right, let's see. Topics. Before we go on to topics, are there any questions about uh, logistics? Where is the exam going to be on Gradescope? On what day? May 11th. What time to what time? Afternoon, May 11th to midnight. How long will I have it open for? 3 hours. Countdown starts once you access the exam. You will need to submit and make sure that all your submission has gone through okay. Give yourselves good amount of time to do that process. In the past, you have given it 15 minutes, maybe you have given it 10 minutes, depending on how your workflow was set up. But give yourself some time to kind of wrap that up. Make sure the submissions go through okay. Let's see. Are you allowed to tell us the number of questions? Yes, I am going to tell you the number of questions, and I'm going to tell you what is the format of the exam. Yes, yes, we are going to do that. All right, topics. Some of the things that I want you guys to sort of review, make sure that you understand that. Two's complement. Why is two's complement extremely important? Because that's how the actual arithmetic is carried out in real systems. So you are not going to find a final exam without me testing you on the concept of two's complement arithmetic. How do you represent numbers? Whether they be integers or they be fractions, how do you represent them in two's complement representation? How do you do unsigned or signed arithmetic? You will be asked a question there. The format may depend. It might not be a free response question, or it might be, but make sure that you review your two's complement representations. They are quite critical to what we have learned. Signed magnitude arithmetic, not so much. What is that? Final exam is just a 8 variable K-map. No, can't do an 8 variable K-map. Um, I'm also going to be testing some fundamentals of number system conversions. So some things that are, very, very common. For example, binary, hexadecimal, octal, and decimal, right? Are you able to go between one to the other? Uh, in other words, the complex number system conversions that you guys did for exam one, where you were going from base 3 to base 7 and all those calculations that took a lot of time, that's not going to be something that I would be interested in testing. However, I will be examining your conversions for the common number systems. I'll just write down the numbers here: 2, 8, 16, and 10, of course. Because that's what you will take away from this class. That's exactly what I want you to retain from this class. Uh, okay, next, let's talk about digital circuits. We talked about how do you design or how do you implement logic functions using MOS transistors. Where should I put my NMOS transistors? How should I configure my pull-up network using my PMOS transistors? The concept of noise margin, in my opinion, that was a pretty important concept. And what is fan out? What is fan in? Why do we need a buffer? Those kind of ideas, you guys need to kind of refresh those important ideas. In terms of numerical problems, there weren't any in that area. Noise margin had a simple subtraction operation involved. But you know, for you to take a logic function and see it in terms of transistors, right? So, okay, I need to connect NMOS transistors in series here, and my PMOS transistors will become parallel in there, and so on. Um, I don't want to. You can't stress enough how much I don't want to take this. You don't want to take the final. Yeah, it seems like a lot of information, but I'm essentially asking you guys to refresh your memory about these things. Could could you give us all hundreds? Guys, so here, the things that you guys are talking about in terms of giving people 100, you see, I'm the coach and I'm the referee. I hate to be the coach and the referee at the same time. Uh, I have to kind of um, do things as the system indicates right now. Uh, yeah, but the problem is I'm also the referee, right? That's the problem. Uh, if there was one coach and somebody else was refereeing, then that would be very fair. All right, let's not go into the philosophy of the education system. Let's come back to our final exam now. Boolean algebra. You will be tested on some of the Boolean algebra properties, but this might be not very explicit. So I'm not going to be saying, okay, here is a logic expression, minimize it. But you will need Boolean algebra in order to analyze some of the other things. So for example, if you have a finite state machine design analysis, you may need Boolean algebra to support that minimization. Uh, I'm glad to hear that the exams have been fair. I'm going to try my level best to make sure that you feel the same way about the final exam. So far, in the past, people have. Let's see. Boolean algebra simplification, K-map simplification, all those things that allow you to represent a logic function in its simplest form, those are going to be, again, crucial. Um, Anybody curious about who was the winner of that one topic that everybody wanted to remember after 5 years? Or they thought that they would retain after 5 years? K-map, yeah, it was K-map. And I totally agree. So, in other words, you will need K-maps on the final exam, because that is something that is fundamental to our course. Okay, next we moved on to combinational logic circuits. And uh, if you only remember one thing about this class, remember this, yes. So in terms of combinational circuits, we talked about many things. We started with PLDs, we talked about decoders, encoders, muxes, demuxes, parity, comparators, and adders. We did it sort of in an asynchronous manner. We didn't quite do a lot of like a live lecturing on this, but we have done some example problems and we did asynchronous lectures on that. Uh, these are all important, but let me just highlight a few that sort of uh, are pretty important in my opinion as far as you know a long-term view is concerned. Tri-state devices as well. But so all of these things I'm going to highlight over here. Mux is a close second. Yes, we talked about it too much. All right. Next, we moved on to things that were actually, may, hopefully at the beginning they made you scratch your head, right? Like the how do you store bits? What is the metastability? Why is this a bistable element? So we started off with a latch. We made a flip-flop using latches. Then we made counters with flip-flops. We made registers with flip-flops. We did conversions between flip-flops. So a lot of these ideas you have been tested on in your second exam, but I still have them over here. You would still need to sort of review these topics uh, because they will be used for finite state machines, right? If you go to finite state machines, you cannot really build or analyze a finite state machine without understanding how a flip-flop works. And you would not be able to get to a flip-flop without a latch in a master slave configuration. So all of these are sort of in a hierarchy form. We built on top of these things, these elements, as we moved through the course. I want to point out that after exam 2, we sort of stopped here, right? So we stopped here as far as exam 2 was concerned. So let me draw a line here. So everything above that red line was, between exam 1 and exam 2 or before exam 1. After that, those things, it was after exam 2. So things that you guys have not been tested on. Um, you will have to deal with some sort of counter. You may be asked to design a counter. You may be asked to analyze a counter, but a question on counter is going to be there on the final exam. You also would need to review your shift registers. So for example, the 74X, this is too big. So for example, the 74X194 universal bidirectional shift register. Can you use this to make an arbitrary counter that starts at a known value and at an arbitrary value and stops at an arbitrary value? So think about those things. Questions similar to what I just described are there in the back exams. That were attached to exam 2 so section. So you can go and take a look over there. But you absolutely must expect a counter design problem. It's definitely going to be there. So again, an example problem is on the back exam for you to take a look at. I think on the back exam one, I gave the students a particular sequence and I said, okay, generate this bit using D flip flop, generate this bit using JK flip flop, and so on. Have your excitation tables, your um, characteristic tables, characteristic equations handy, right? So if you wanted to make a crib sheet for yourself, and this will be attached on Piazza, you absolutely will need these things. Excitation tables. Don't spend time deriving these for the standard flip-flops. Characteristic equations and characteristic tables or next state tables. You will need these. So make sure that you have them ready on a reference sheet while you're taking the exam. Um, let's see. Oh, I would also, when if I go back here, yeah, if you're when you're doing number conversions, have something like this handy. Come on. Maybe something like this. Maybe you can have something like decimal, octal, hexadecimal, and binary, at least for the first 16 characters, right? So that will allow you to do some quick conversions. So have that ready, right? So for example, you can say, all right, 0, blah, 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 blah 15, and then you can say 0, blah, 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 f, and that, and you can find. No, you should not really be using Google. Um, because open notes, open book, open notes doesn't mean open internet. I would, if you're spending time using the internet, I'm pretty sure you're getting lost in the weeds. Have this table with you, because while you're writing, while you're preparing this table, you're also sort of understanding how that conversion works. It would help you with quick conversions. Uh, you can, but I'm going to give you guys all that information. So if I'm asking you a question that has a 74x chip involved in it, I will tell you what each of those pins corresponds to. The only thing that I will not say is the bubble indicates active low, right? Like those kind of things you guys got to sort of pick up. All right. Right. But in terms of what does active low mean? Yeah, yeah, right. That's the next question that I will not be able to sort of answer in that. Um, but things like, oh, which one is the most significant input, which one is the most significant output, those kind of things I will clearly mention in the problem statement, so you wouldn't have to look up the data sheet. Let's see. Counter design, we talked about that. Flip flops. Okay, 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 okay. All right. Let's move on to the finite state machine. So, finite state machines, the concept as well as the design, these two lectures were sort of pretty. We spent quite a bit of time talking about this topic, and it is going to be pretty significant portion of your final exam. Um, there are going to be two problems that are absolutely going to be there on the final exam regarding finite state machines. One is analysis of the finite state machine. So I'll give you the circuit and you tell me what the state transition diagram is for that particular finite state machine. That's analysis. You're reverse engineering my circuit or the given circuit to come up with a state transition diagram. So it's like circuit to diagram, right? State diagram or state transition diagram. The other question that you should absolutely expect is design. What is design? I will tell you what it should do, right? I'll give you a statements, or I should say description, right? So I'll give you a description and you design, you go through your steps. First, draw the transition diagram. Then with that, you go to the symbolic state table. Then you go to the encoded state table. Then choose a flip-flop. Then draw the digital circuit. At the end, your design should be a circuit. So these two are going to be there. While you are designing, make sure that you clearly state your assumptions. Make sure to clearly state assumptions. Because sometimes these can be very open-ended, and some students might assume certain starting states and what are you doing in certain transitions and so on. Make sure you clearly state all your assumptions when you're doing that design. Now, because an analysis of a finite state machine design is what would be a bad statement of assumptions? Um, well, anything that really doesn't um, do you know, so something like this is a good statement. The user must hit a reset button to go back to state 0, right? That's a reasonable assumption to state. I guess what I'm trying to say is no statement in terms of assumption is a bad situation. So you should be able to write statements that support your design procedure. Yeah, that would be a bad assumption. Um, what was I saying? Yeah, so analysis, right? For analysis of a finite state machine, you would need the logic expressions for a lot of things that you have studied. For example, during this analysis, you will need to rely on characteristic equations of the flip-flops, and you take a look at these. You should be able to look at a particular decoder or a mux or a tri-state device and be able to say, okay, this is how the logic expression is going to change. In exam 2, you guys actually did a analysis in which there was a multiplexer and a decoder. So try to review those ideas because you will see them again in the analysis of a FSM for the final exam. Okay, so I guess in terms of final exam, have said that, and of course, analysis and design of FSM, determining what type of FSM is it going to be, how many flip-flops is it going to need, and so on. Um, all of those things will be a free response question. Yeah, assume 1 equals 0. That's the end of our course then. All right. So the last thing that we talked about in this course was memory. We talked about the two types, major types, non-volatile and volatile. Non-volatile was essentially used for BIOS of a computer program or any kind of startup programs that need to be loaded when the computer system starts up. They do that in ROM. We looked at a NAND and a NOR based structure. We also looked at a diode based and a general MOS based ROM. So we had stopped in the last lecture at diode based ROM. Today we looked at MOS and ROM and NOR and NAND based structures for ROM. So you should be able to do two things here. One, if I give you guys the structure, you tell me what is stored at what location. The other is I will tell you what it should be storing and you tell me how the circuit would look like, right? So you guys should be able to go between from one to the other end. Again, this is analysis and design, right? You should be familiar with where do you need the inverting buffers, how are the row decoding, how is the row decoding working, the fact that only one word line can be active at any given time, the number of word lines depend on the number of input bits, address bits, and so on, right? So those kind of things will be questioned. Next, volatile memory. We looked at essentially the structures of a static RAM and a dynamic RAM structure with 6 transistors for static RAM, and for dynamic RAM, 1 transistor and 1 capacitor, and a refresh cycle was required there. So maybe some short questions in that regard in terms of this is on the quiz too. Yeah, that's right. This is on today's quiz as well. All right. Now let's talk about the format of the exam because you guys are so curious to know. Now, I will have two sections to the back exams, to the exam. One is sort of a short answer questions, which will be about 8. This might change a little bit depending on how much time I think at the end they will need. But I do not want you guys to spend more than half an hour, maybe 45 minutes on this. 30 to 45 minutes. Don't spend more than that on that. Yes, there will be multiple choice questions. Uh, so here, there will not be tricky multiple choice questions where, it's not going to be trick questions. It is going to be whether you are able to understand the context or not. Right. I got to be, as much as I know that you guys are I know that you guys hate it, but I got to be consistent with the way I do exams. Um, so there will be some questions that are, I know, I know, Andrew, you did, but you see, there are 107 other students in this class, right? So I got to think about how I do my process. Um, so let's see, multiple choice questions. So, you know, one answer is right. Select one out of many, or it might be multiple answers. So multiple choice with in which you will have multiple answers, and I will state that in the problem itself. Um, I'll say select all that apply and so on. Um, so about 8 questions are going to be there in this one, and I don't want you guys to be spending too much time on this, 30 to 45 minutes. So what type of questions are really a good short answer, right? So something like conversions can be a short answer question. Something like, a very short K-map, a three variable K-map. Maybe that's a very good short answer question. So things that typically should not take you more than a couple of steps to get to the answer. That's what is a good short answer question. Um, so I generally reserve that for topics that were in the initial part of our course, right? Number systems, digital circuits, Boolean algebra. I tend to use more of the short answer questions for those topics, uh, because then it's sort of a clear answer, right? There can only be one way to convert from binary to hexadecimal, and so on. Uh, Wait, so this is like only 1 hour. What do you mean? No, that for short answer, I recommend. This is a recommendation that you do not spend more than 45 minutes on short answer, not on each, for the whole section. For the whole section, don't spend more than 30 to 45 minutes. All the other time that you have, spend on free response. What you will have 2 hours 50 minutes, or 2 hours 15 minutes to 2.5 hours left. Spend all of that on your free response questions, and of course on your scanning and uploading. Yes, yes, yeah, because that's so short answer questions are uh, that's my recommendation. If you guys want to spend more time on the short answer, that's fine, but the free response questions carry more weight, and you are able to get partial credit and all of that stuff, right? Yes, short answer is supposed to be short, that's right. So don't spend too much time on it. um, Take 2 hours on the short answer, then panic through the free response, then it's going to be the worst case scenario. I would hate to see that happen. So all I'm trying to say is budget your time according to how you see your points being distributed, right? So usually my short answer are maybe 30%, 35%, but the remaining is free response questions. So accordingly, split them up. Uh, yeah, so you can also you know, uh, find out the percentages and all that. Okay, I guess this is all I have for you guys in terms of the review. Um, if you guys have questions for me now, I can take them. Like I said, I will be, um, once the exam gets done, the TAs are going to be working on grading it as fast as we can. I'm hoping that they also get done with their courses by then. And once the things get graded on Gradescope, I will be releasing the grades and I will give you the solutions to verify. But that verification time is not going to be a pretty big window, right? In the past, it has been, sometimes it has been 12 hours, sometimes it has been 24 hours, but it's a pretty short window in comparison to the regrades window that we got for exam 1 and 2. But you will have an option to go through your exam and send in your regrades. rest the time. So I guess we already know some of the questions, don't you think? We already know what type of free response questions are going to be there. Um, the FSM analysis is going to be there. Yeah, analysis and design. There is going to be a counter design there, right? So we already know quite a bit of the exam. In these 8 questions, you know what's going to be there. There's going to be conversions in there. There's going to be two's complement in there somewhere. Um, so cascading anything, maybe. I can't really say. So my good question ideas usually come from students. So you guys should feel free to give me them. All right. No cascade. All right. So what are you saying? We are not going to be doing any dishwashing then. Yeah. So you know. So I don't I kind of get your point, Andrew. Drawing can take up quite a bit of time. So I have that in my mind while I'm making the questions. I don't want you guys to be drawing things, spending time on drawing things out. Um, in some cases, I really cannot get away from it. For example, FSM design, right? Okay, sketching up a state machine is state diagram is sort of important there. Yeah, so I can't get away from there. But yeah, I get it. I don't want you to be focusing on you know spending too much time on doing something that really is not critical to the exam. So it's on my mind. So I will stay away from those kind of questions which are going to require too much time. It's hard enough in logic works. All right, what else, you guys? This is a recommendation, by the way. Don't you guys please do not use this as something that you know. I only spent 45 minutes on it because you asked me to. No, no, no. This is just a recommendation. Like, if I was taking the exam, I would have budgeted my time this way. You, of course, can do it your own way. Well, not, no, as in if way back. I've got to write the exam first, then I've got to spend time writing the answer key, and then we'll see. Like it's going. So that's that's my next week. I will be writing exams and writing answer keys, and I've got to do that before my surgery. So I'm on a tight schedule there. What do you think this class was about? Andrew, you got to stop giving me things to roast you. All right, you got to stop that. Oh my gosh, this kid. No, I can't. I can't. It's maybe if you were in person. Maybe if you were in person and no, it would be easier to do it if you were mean, but you are not mean. No, his recording is not done. We are still recording. All right, questions, you guys. I'll stop recording now then.